Okay, hello guys. My name is Yash Kumar Verma and I'm a Microsoft student partner and I do backend development. In this particular live stream, I'll be showing you how to set up a basic CI pipeline which you can use in all the backend developments that you do, so that all the tests that you write and all the scripts that you make, all the build scripts and everything run once you push the code onto the server. So we'll be implementing that from scratch in this particular live stream, and we're just waiting for a few people to join and then we'll be starting off. Okay, so I guess this might be the perfect time to start. Okay, if some of you could tell me if the audio is right now. I should be audible. Yes, I guess I should be audible by now. Could any one of you please comment and just confirm me, so that what I speak is actually heard by you? Okay, I think we have green signal. All nice and good. So okay, I'm increasing it to a bit more. You might hear a bit noise as well now because I am boosting it from it and shift so that I am also visible. Hello guys, my name is Yash Kumar Verma and I'm a Microsoft student partner and MLH fellow, which is currently working along with Major League Hacking and doing a fellowship there. I do backend development mainly. And in this particular stream, I'll be telling you how to set up a CI, how to set up CI from scratch. And the software that will be like the service that we are using is called Travis CI. Now this particular this particular service is free for open source. You shall face like no issues in using it whatsoever. I am sharing this link in chat itself, so those of you who are interested can go and check this out. So let's start. There are two things that I can do. I can write one thing from the very scratch. One thing, first method. The second thing is I use one of my old projects and then demonstrate how CI is being used. To keep things short, what I'll be doing is I'll be using one of my old projects, like not exactly very old, one of my old projects in which I have used CI, and then demonstrate how it is done. So first of all, to give you a basic overview of what exactly can we achieve using CI. So sometimes what happens is a lot of people are working in a team, and what you need to do is you need to test the changes as in when they are made. For instance, you cannot like merge everything that comes in. You need some parameter to check if it's working or not. So in open source, what we do is, since it is like it happens almost 100% of the times that people would be making pull requests that would break things. As I mean that they would be disrupting some of the old functionality. So to prevent those, what we do is we write checks, we write tests, and whenever someone makes a pull request, what we do is we run those tests every time, and that is what the job of CI is. CI is basically called continuous integration, and it basically ensures that everything is continuously intact and there's like no loopholes or anything like that. So if I could get a green signal from you guys in the comment section, I would start demonstrating how to use it. There's a bit of lag in the stream, so I guess there'll be a few seconds gap somewhere. Okay, so let's get started. So this is the project. You're free to fork it. It is available on GitHub. I'm sharing this link. So what I'll be doing is making you deploy it yourself, and then let's see how we are going to use CI in this. So I'm sharing the link of this in the stream as well. Right now, you all also have the link to the project that we are seeing. So what you do is you click on fork, and then you fork it to anywhere you like. When you will fork it, you will get a local copy to your personal account. And then now let's see how the CI would be working in this particular project. I'll show you the directory structure. Now, if you're interested in this particular extension, it's called Octotree, and it basically allows you to browse the code in a very efficient manner, and it's like very nicely integrated with GitHub as well. It's free and open source. What you say is you see a file name as travis.yml. Now this travis.yml is basically a configuration file that is used by Travis CI. Right? This particular service, it's a continuous integration service, free to use for open source organizations, and this config file is used by this particular service to run the tests, or in other words, to run the changes that we have made, to run the builds as they're called. Right? The exact word is build. So whenever any changes is made, it triggers a build, and that is what we will be seeing now. So I'll quickly walk you through the configuration file here. So see, first of all, we specify the language. Now this you can read more about the documentation, more about the configurations that you can have in this file. This file is named as .travis.yml, and it has to be named this because the service looks for this particular file. And first of all, we specify the language. The language written here is Node.js, right? So the application that we are trying to integrate, that we are trying to use CI on, is using Node.js. Now the services. There might be a few services that you might require. For instance, if you are writing a backend and you have integrations with database as well, then you might need to actually connect to a database to perform some tests. So in that case, you need a MongoDB service. MongoDB service means like you need an instance of a database. You need a database service when you are running the build. By build, I mean when this CI is running your tests or is running the script, is running this particular script. So build is a jargon in CI that we use. Build means work. So whenever this CI is working, this uses these services. Now this particular thing is this particular thing is a configuration for Node, which version of Node you're using. It is usually recommended to not use the bleeding edge version. By bleeding edge, we mean that the latest version, that's the jargon that's used. It is not recommended to use the bleeding version. In some cases, there is. For instance, when you are writing a very big application, you need to be sure that it works in all the versions. So what you do is you run multiple builds on different system versions, and that is how you ensure that your particular software is working fine in all of them. Okay, and now there are a few steps that you can specify. They are like install, pre-install, script, success, before success, after success, deploy. Now all that you can find in the Travis CI documentation, and I'll have to quickly search this up. Travis CI documentation. Right. So I'll be sharing this link in the chat. Now you see that privacy tutorial. You will see a number of languages that are listed here. So I select Node.js, and it basically shows me all the configurations that I can do in one particular page, all nice and easy, as I showed you. The language, the versions that are here, and yes, you can also specify whether do you require sudo access in your code or not. Basically, these are used to test the packages that you write. Sometimes you want to make sure that a user does not need sudo or admin level access in Windows to run a package. So we run the tests by disabling sudo in that. And just I want you to go through this thing once, like whenever you are trying to, because this will provide you with, like, there are like very beautiful examples given here which basically enable you to like write very good tests, very good build, very good build configurations. Now what we're doing is we are installing Google Chrome, because that this particular service might be using Puppeteer or any other thing like that. So all the things that you require are like specified here itself. When you see dist trusty, this basically requires a particular Ubuntu version, or you can say a Debian inherited versions. env are basically the environment variables that we want to use, and then rest things are simple. If you want to, can read them up. So I'll be doing the basic, very basic thing, just to get you into a feel of it. So the first command that we are using is install. What install does is basically this script, if you search it up, it would be given here as well. So yeah, if you check out, once you start reading the documentation, you will see that there are particular sections which, if fail, would stop the build there itself. There are particular sections which, even if they fail, they would keep continuing the build. So that is how you keep the optional things and the important things into different segments, and that is it. Now the first step that we have is install. So what it does is it installs TypeScript, right? Because we are using TypeScript to compile the code that we are doing. And then what it does, it runs these particular commands. Now these particular commands, I'll show you. Now I'll show you from where are these particular commands run: npm run, lint, build, coverage, and code conf. Yeah. So my editor should be up and visible to you now. To all the people who are working with me on the guided project, that is the reason I had made you go through this particular application, because this application you can like take it as a reference freely, and you will get a lot of things to learn from it. Okay, and the configuration of all the node applications that you write are there in package.json. In package.json you specify the name, the version, the description. The description is basically useless unless you publish it on npm. Then these are the scripts that I had mentioned. So moving on, see, first of all I run npm run lint. So what lint does is lint runs ESLint on all the files, all the TypeScript files which are in the src folder. As you see here, you see the src folder. It runs the linting tests on everything. Then we have the build command. What the build command does is it runs the tsc command. What does tsc do? Tsc basically compiles your application, not compiles, transcompiles your application from TypeScript to JavaScript, because TypeScript, as we know, is a superset of JavaScript. So we need some application to transcompile it back to JavaScript so that it can be used even without a TypeScript compiler. Now the next is coverage. Coverage, what it does is it runs this particular long command. I'll be using it for you. See, there's a command known as test here. What it does is it runs mocha, where it runs on all the files in the test directory. So if you go through the test directory and you see all these particular files, what you will see is you have 4 files, and I've used this function --sort. This basically enables to run the tests in an chronological or alphabetical order, whatever you feel like. So that is why I've named them as 1, 2, 3, 4, because the way I've written these tests are, the first one creates a user, the second one interacts with the same user in the database. That is why I had to specify a chronology here, because obviously I cannot make a request from a user that does not exist. So the first one is just like a template which runs an instance and clears the database and everything. The second test basically tries to create a new user, make sure it throws an error, like tries to handle all the edge cases that we can have. So back to package.json, and just in case if you wanted to know how did I like search for the file, it's Control P by default. So and you write everything here. For instance, I want to open Docker file, then I want to open package.json file. So that is how you quickly move across the files. That would become very handy once you start developing more and more applications, because like searching from this side actually is kind of slow sometimes. Okay, now the test, the coverage was some of you might not be like very clear with coverage. Coverage is basically we try to run the tests on as many lines of code as possible. The reason is we want to make sure that all the lines that we have written, are executed at least once, and that is how we measure coverage. So if a project says it has coverage of 100%, it means that each and every line that is written in that project has been it has been tested, like some one test or the other has at least run it. So I'll be first of all, basically what I do before committing is, when you are working alone, you basically do not require all this extensive setup, but once you are working in a team, yes you do. The reason, because let's say I run npm run lint. What this would do is that this would check for linting errors. See, it triggers ESLint, and if there are errors, it would show us. If there's not, it would simply pass. Okay, it shows us this one warning, and it says do not use console.log. So this particular file, you control click on it, you can open it, and it says line 61 column number 6. So I go to line number 61 column number 6. I see there's this console.log error landing page, and so I just comment this line, or maybe remove it and remove this as well, because I guess we are returning a response, so there's no need for are we including a logger here? Okay, we do logger dot, let's leave it for now. Okay, right. Now once we run npm run lint again, so lint just told me that it is not a standard thing to use console log statements in Node.js application, and it showed me a warning. This particular thing ran on my local system. Now this my local system, keep this in mind, it ran on my local system, not on the server. I ran the linting test, they went fine. I ran npm run build. So if, as usual, I have not made any blunder, which I usually do in the in writing a TypeScript application, this should compile. Okay, yes it did. It means that our application in general is working fine. It is building fine, right? It is transcompiling fine. There are no errors in types or similar things. And then let's see the next command which we need. We say okay, npm run coverage. We say npm run. Okay, let's first run the test. Npm run test. What this does is it starts a Mocha instance, and it has a timeout of 5 seconds per test. The first one takes a bit of time because it basically clears the database, and the remaining would be done pretty quickly. And the tests failed. Okay, interesting. Now you see that, like, do not pay attention to the error thing. This is generated by the logger itself. You should focus on the sticks and process that you see. So as you move down, you see, okay, new event created successfully. Should successfully create a first event. Okay, all these are unit tests. We are trying to test each and every component of the application. And testing session start, and okay, should create session with proper data. It took 57 milliseconds, so it's highlighting us. So that is what tests do. They basically ensure that all the things are going fine. And see, whenever you make changes to a code, you cannot do all these tests manually, right? You cannot just go and create a user every time, validate with different types of usernames. So that is the reason we write tests. Now this particular test has ensured me that okay, all these things are working fine, but 38 of them were passing and 2 failing. Now that's an issue for us. But what we'll do is we will not fix those. The reason I'll be pushing this code to the repository and see how the link and see how the CI services work for us. For instance, I am a contributor in some particular project, and I am very notorious. I do not, or just in case I do not want to fix all these errors, and I say, okay, I do not know this ever happened. Now what's the proof? If you're not checking the same thing on the server side, this particular code will be merged to the main repository, and then it will start creating errors because, like, as you see, it has thrown some 2 tests have failed, means 2 components are there which are not functioning as they should be, right? This should be true, it is expected as false. It means something's fishy, right? So what if I say like, okay, I do not want to do this, I just want to merge my work, and all I do is this never happened. I just cleared the console, nothing happened. The maintainer does not know what has happened. No one knows what has happened. And the last one is code cop. Instead of code cop, we'll be running coverage. So I say npm run coverage. What coverage does is it basically runs the test and then sees which all lines were executed by the test. So this is particularly useful in ensuring that what all components are actually tested and what all components are not tested. So let's wait for a few seconds till the time this tests run, and all the 40 tests are passing. Okay, so it means there is some discrepancy in one of the tests, that they are arbitrary passing or failing, or what might happen is, if you might guess, the database that the tests use are not cleared before using, and that is the reason, like, there was some error in creating a user and the test failed. Now what to do in such a situation, right? In your local system, the test once passed and once failed. The reason is, if I show you my databases tab, sometimes the outcomes of tests are very dependent on the local changes that you have done. You might have a particular configuration that everyone else might not have, and in things like that, your test would basically perform according to the environment specifications, and they might give different outcomes for everyone. Just like you saw this particular test, I did no changes whatsoever. First shows, okay, you can see here, it showed 38 passed and 2 failing, and here it shows everything is passing. So in my particular system, one test is giving 2 results. So how do we ensure that there is like no discrepancy like this, right? So that is the reason where CI comes into play. Like, no one can forge that yes, the tests were working, they were passing in my local machine, it does not matter. Even if they pass in your local machine, it does not matter. They need to pass in the server, because we assume that the server configurations would be used by everyone. So this is my database, and this particular extension is the Azure extension. It allows you to basically browse easily. There's like no Azure account needed for it. It's a Microsoft extension, and this particular code editor, as you know, is VS Code, and there are 2 users. So that is what happens. Sometimes your test might be influenced by your local changes, as we have just seen in this live stream right now, and this would have generated a coverage report. So what exactly is a coverage report? A coverage report is basically a detailed report which shows how the tests are running and like supplementing our work. So the coverage report is in the coverages lcov folder, not exactly in docs. We open Google Chrome, coverage lcov report. Okay, index.html. Okay, I'll be answering the questions at last. It's a stream, you can always like look upon it, and you see that the src folder is 100% tested. Each and every line is tested properly. Okay, let's take the questions up so that we do not have a backlog. Are the packages like Mocha available on Travis by default? Yeah, this is nice. Let's keep it on a separate screen. Keep it full screen. Nice. Now I can remove it. So it says all the packages like Mocha available on Travis by default. The thing is, Travis is not a package itself. All these packages are, see, Mocha, Chai HTTP, all these packages are available on NPM, Node Package Manager. Travis is a service that uses these packages. So there's no clear-cut connection between them. One service uses the other. It's not that Travis would include these by default. If I show you the build script right now, the package.json and travis.yml. Travis.yml for Node applications runs npm install by default, right? So when you specified Node.js, it expects that there would be a package.json, and with that package.json, it would install all the dependencies that you have. So if you quickly go through package.json, you would see Mocha here. You see that yes, Mocha is a dependency. So whenever your build would be running, it would run npm install. So I would recommend to try running this particular project in your local system, and when you do npm install, this would install all of these things. So these types are needed by TypeScript and Chai HTTP, CodeCoff, ESLint, and then all these other dependencies. So Mocha is installed here. Let's see any other question. We say please upload the video after streaming. I guess YouTube enables viewing stream after it ends, right? Yes, it would be a public after it ends. You can always refer it, because some of the participants wanted this to be recorded, so I decided not to do a Google Meets call, instead do this. So where were we? Okay, we had run that test and everything locally, right? So now let us we say git status. This one file we have changed. Let's check the logs. Okay, so what I do is git add everything, and then I say git commit. Let's see what are the changes that we made. What we did is we say git commit -m user not late by default. Okay, new attendance not late by default. Is late equals to true. Okay, what exactly are we doing? Okay, we just change some variable names, and that's called refactoring. Those of you interested, quickly search up for the term refactoring and see what exactly is. You do git status, I say git add all, git commit, and say refactor controller, and say external to fix linting issues. That's right, because earlier they used to have we were getting one linting warning, and now we are not. So let's assume that it's going the right way, and I say git status. It shows you there's nothing to be done, and I do git push origin master. Or should we not? No. Okay, we should. So changes are being sent to the master branch. Nice and good. Now once you open this, what you will see is any new messages. Okay, feel free to message whenever you want, and you will see this particular yellow dot. It shows queued. The build is queued. Okay, let's dig deeper into it. So right now we have just pushed the changes, and Travis is working for us, and it says your build is queued. The build is created. Okay, nice and good. It means, and you can see the build configurations that are being used. These are passed from where? .travis.yml, and this is the JSON format that you are seeing right now. And here you have, this is the build you're working. So for some of you who might try to replicate what we are doing in this stream right now is you might not have Travis integrated. So what you have to do is you have to go to GitHub applications and then install Travis on your particular account. So somewhere in this logs, I'm sharing the logs in the chat, so you can just quickly go through them. Right, I have shared logs. So let's see what what Travis does for us. It cloned our repository, okay, and then what it did was it opened the folder, okay, and then this is an interesting thing. There are 4 variables that it has exported. I'll be throwing some light on that now. So you should go to settings. This is particularly a thing I should not go to in live stream, but still, for the sake of open source, let's do it. I have these 4 variables here. Now these 4 variables are basically things like sometimes you want to use some secret things, like you are deploying somewhere and you need a username password there. So you might it is not at all recommended to use things it is not at all recommended to use all these things committed in the repository. You will never see a .env file here. You see, do you see a .env file here? No, but once we go here, you see that yes, there is a .env file here. I cannot show more of it, the reasons being, okay, I can show that it is only half of it. So all these are the secret keys that I have. I do not want these to be shared publicly. So what I do is I keep them in .env here, and if you want to supply any environment variables for the build, what you do is you add it here, environment variables, and you add the name here, you value here, and make sure you keep this off. So what it does is it will not show the value in the build script. So now what it does is it checks the node version, it checks the npm version. I'm going line by line so that you're very clear with it. It checks the npm version. It says okay, install TypeScript. TypeScript is installed. npm install is done by default. There would be some command of it. If you view the raw logs, you would see npm install somewhere. Okay, you'll see npm install. It's done by default. There are no issues there. To that, now it ran npm install TypeScript. Now see, it has started running all the commands that we have mentioned in the .travis.yml. Now we run npm run lint. Now you see one thing. Even if a contributor is trying to ease their work or trying to act over smart somehow, or trying to maybe avoid the work from their end, we always ensure that the code that is being merged is always well tested and is of high quality. So we run the linting test on the server as well. So what it does is, irrespective of whether you send the highest quality code or a code that you wrote, you are almost half sleeping like I do usually, so it won't be an issue because everything is checked on the server once. And please make sure that exiting with zero does not mean that it's an error. Exiting with 0 basically means that it has run successfully. 0 exit code is considered to be a success exit code. Now we run npm run build. It ran successfully. Now let's see. It ran the coverage test. For the coverage, see, I have not explicitly run the npm test script. The reason to check the coverage, we have to run tests once, and there is no point of running the test again in order to check the coverage and for the test to pass. So when we are checking the coverage, the tests are run. So I guess once is enough. If you have any questions, you can comment there. I'm checking them periodically as well. So all the tests, as you see, are being run on a third-party system. Your local configurations do not matter here. It's only the code and a new fresh service. Your existing changes, your local configurations, your custom configurations, whatever hacky things you are doing, anything does not matter here. All these things are running on the server, and you see all the tests are reading. Should not create an event with all entries missing. Should not create an event even if one entry is missing. Should not create an event even if one entry is missing. Like even if when do not create when event name is missing, when slug is missing, when description is missing. All these things. The ticks in process are generated by Mocha, and it's a test runner. And this info and error that you see, this is not basically an error. This was intended to be an error because it should throw error creating a user with the same username. So yes, we wanted an error there. The reason being because somewhere in code we would have, if I can show you, somewhere in code we would have written some written some logic to handle the errors, and we want our code to run that as well, right? To make sure that we can handle the errors well. Our code does not basically break when we see an error. So if you open this, so what you see is the auth module. The auth module is not a very good example. src app.ts, everything is run at least once here, and I'll show you the users module, the controllers, and it basically shows okay, everything ran, but this never ran. Now why this never ran? Because this particular thing runs if there is like some error in the database. So for optimal testing we might somehow need to like run this as well. The remaining lines on the left side shows how many times they have run. This particular ran 4 times, 6 times, 8 times, 5 times. So it was it is never intentional to run one line multiple times, but sometimes it cannot be avoided. The reasons being, if I'm trying to check the edge cases, then we might need to run a single thing multiple times. For instance, here we are testing even if do not show an error, even if one thing is missing, even if event name is missing or slug is missing or description is missing, these are local things. Even if one thing is missing, we want to target each and every edge case just to be sure that everything is handled. Everything runs and it says 40 tests passing. So where the place where we saw that 38 were passing and 2 failing, that was basically because of some of the local configurations that I had. And on the server it must pass, and that is all that matters. No one listens to you. I'll tell you the story of open source. No one listens to you when your local changes work. They must be working for everything or it doesn't matter. That is the harsh fact. And then CodeCop is basically a service which allows you to test the coverage reports, test and generate coverage reports. We had a script for it and we have run CodeCop. And here you see some ugly output, just forget it for the time being. And here we say, okay, we are logging into Docker because I do not want to show my username and password. So it's everything in the form of variables which are stored as secrets, so you cannot see them. And even if everything is visible to you, you cannot do anything of it, right? If you guys are online, try commenting something. I have absolutely no response, and maybe you are too busy in understanding things. And it basically makes a Docker container and then it uploads it on the Docker Hub. We'll be covering Docker some other day, and all this is generated from Docker and it uploads. Now one interesting thing, if you check out my travis.yml, I used something cool here. I say search project lcov report domain on this particular domain. What it does is basically search is basically a service which allows you to deploy static websites free of cost. I am particularly using 2 code coverage checks. One is CodeCof and the second thing is lcov. CodeCof is a particular professional service. It uses the lcov reports. Too much jargon. If you're not able to understand, chill. It is sometimes difficult to grasp a lot of things in this particular short period of time. So I am making sure that even my lcov reports are uploaded. So every time my tests run, every time my build runs, this particular site is updated. And externals modules, if you see only 33% are ref, this is a poorly tested application, this particular module, and it shows that which thing needs testing. You see src modules external, this is what needs testing. So what we do is Yeah. So you see only that only 28% of the tests, like all the of the lines, were tested here. The reasons being this particular module was written very recently, and okay, you see all these things were not all these things are not being tested as of now. So I'd be writing test for them somewhere later, and that is what happens. If you write test, you'll see. Okay, let's scroll down, and it says done. Your build exited with 0. Let's see the GitHub report of it. It says the build passed just like the previous build. It means that the changes that we have pushed were successful and they were not breaking anything, and everything is in safe hands. And it shows last commit. It successfully ran. The build passed, and it was completed about 12 minutes ago. So that is basically it. How you are working. And one more interesting thing. We still have time in hand. So you see all these pull requests that were made, and middleware test. Okay. When you're using services like CodeCov, so you might ask why am I using some things like CodeCov or LCov? CodeCov, you see this particularly beautiful output here. What it does is it tells how much more coverage the tests are doing now. This is particularly helpful when someone sends a PR, a pull request, and you would see that even the pull requests are built. You will see a small checks here. Yeah, you see that Travis is building even the pull request, so it does not mean that the test would be running only when it is being merged. Even when you make a pull request, I would see a little output here which would tell me that okay, this is passing and all these things are failing, and the CodeCov would show me how the coverages have changed, and that is basically it. How and when it comes to integrating CI. Now this is a very basic thing. The advanced things include deploying the application into onto like some better service, or deploying it on attaching a cluster to it and then deploying it there. So that is how it works. Now I'm opening for questions if you have, or you can try contacting me later on if you have any questions related to it. Those of you who are working along with me in this project would be like working on this as well, as I said before. So if you have questions, please, I guess this is the perfect time to ask them. And we'll be signing off with like in the 7 minutes we still have off in hand. Any questions that you have can be asked right now, or if you want to try contacting me later on, or if you find any particular issues in this particular project, then feel free to submit an issue, file an issue, and maybe we can sort it out someday. And with that is basically it, how we set up a normal CI service. Now, I did not cover the Docker thing particularly in general. That is completely a different topic. That is not necessarily a part of continuous integration. And do not think that this is the limit of CI. CI does a lot of things. For instance, if you see bigger projects like VS Code itself and other things, then you would see that CI services are actually used to build the latest application and then deploy it on the internet, or maybe enable the download links, or do the heavy lifting like compiling everything from source. That is everything done on CI. So I guess this is it. I'll be closing the stream now. It was nice being. You guys have been an awesome audience. Thank you for being.